Parametric functions, day 1. All right, let's take a look at what parametric functions look like. They're when x and y are described in terms of a parameter, and parameter a lot of times is t, and standing for time, but it can be other things as well. So the position on the plane is described by the x-coordinate and the y-coordinate in terms of t. The equations are called parametric equations, and it's called a parametric curve. The c to t as a parametrization with parameter t. Okay, let's go ahead and identify the curve that's being described here. We do that by actually graphing it by finding the points. So x is equal to t squared minus 2t, y is equal to t plus 1. Let's go ahead and put that in the calculator. To get into parametric mode, you have to go into mode, and you have to make sure you're in parametric form. You then go ahead and put it in y equals, which I have done. And I have already set up my window so that I can see something very similar to that. And there's my window, -2 to 2. My step size is 0.01. Now I can find the table by going to second table set, and I'm going to start my table at -2, and I'm going to go up by 1. So I'm going to do second table, and here are all my values from -2 to 4, and so I can copy all those down in this table. Now let's take a look at the graph, and the graph will be here, and this is how it's going. Okay, it's important to indicate when you do a graph, it's important to indicate the arrows at which how the graph is progressing as it's going through the points. Okay, what curve is being represented by the following parametric equations? Let's go ahead and put it into y equals. And so I'm going to clear here, go down, clear here, go up. This is going to be cosine of, I choose a variable key, and in parametric it's always going to be t. And then sine, choose a variable key, it's always going to be in t. I'm going to go to my window, and I want t to go from 0 to 2 pi. You can actually just write 2 and second pi. And I'm going to do -2 to 2, and then -2 to 2. And I'm going to go ahead and graph. So because of the pixel size, because of the screen, which is not squaring, this is showing an ellipse. But if I go to zoom square, and zoom square is the number 5, let's see what happens now. Now the window is squared up. So it looks to me like this represents a circle. And let's go ahead and see if we can eliminate the parameter and just put it in terms of y and x so that we get this. All right, so what we're going to do is we're going to square x, so x squared is equal to cosine squared t, and square y squared is equal to y squared t. And we know that cosine squared, this is our identity, sine squared t is equal to 1. And we're going to resubstitute x squared plus y squared is equal to 1. So just as we had predicted, this is a circle. It's a radius of 1 with origin, with the center at its origin. All right, let's sketch this curve with parametric equations. And the strategy is to go ahead and use a table to help yourself. And then again, always put an indication of how the graph is going. And this looks to me like it could be a parabola. So let's go to the next screen, and we're going to talk about how can we eliminate the parameter. So we know that x is equal to 2t minus 4, and we know that y is equal to 3 plus t squared. So I'm going to solve for t. This is going to be x plus 4 divided by 2 is equal to t. or I can say 1/2 x plus 2, and then I'm going to substitute that right in here. So this is going to be y is equal to 3 plus, and then I'm going to write 1/2 x plus 2 squared. So this is going to be y is equal to 3 plus 1/4 x squared plus, let's see, that's going to be 2x plus 4. And what I'm doing is I'm squaring this, and I'm getting 1/4 x squared, and when we multiply this, it's going to be plus x plus 4. And so if I clean it up a little bit, let's go back to the picture and see if we really have a vertex at 0, 7, or a point at 0, 7. Here's our point at 0, 7, and our vertex ends up here. All right, now these are examples that come from the handout that I gave you, and these are 3 examples. The author does a really good job of showing you making a table, sketching the curve, and indicating the direction of your graph, then eliminate the parameter. So here's all the steps. Again, I highlighted indicating the direction. Here's the next step. Again, graphing, finding the table, graphing, put the indicator of how it's going, and eliminating the parameter, getting x, solving for t, and then substituting, and we get this. Now, how come we don't get the whole parabola? Well, that's because there's a restriction on x. Because t is in a square root, we can only use positive 0 and positive values for t, which forces our x's to be only greater or equal to 0. So that's why we're only getting half a parabola. And here's our last example. Again, I want you to notice that these y values are going through here, so that's an indicator of how the arrow goes. Eliminating the parameter, getting t by itself, substituting it in, and because the t is restricted, so is the domain and range, and so that's why we're only getting y values from -1 to 3/2. So we don't get the whole parabola because in our t's, we're not getting all values of t's. And this is the end of the screencast.